We will now do projectile motion B, number 4. And projectile motion B, number 4 says, a cannon is fired over level ground at an angle of 30 degrees to the horizontal. The initial velocity of the cannonball is 125.6 meters per second. Drawing the picture of this, I have a cannonball being fired at 30 degrees from horizontal ground at 125.6 meters per second. First thing I need to do is write down my initial variables, but to get those, I need to take the components of my initial velocity. Unlike projectile motion A, where my VIY was always 0, in this case I will have an initial velocity. So to calculate those, I write VIX, which is just equal to VX, is going to be VI, which is the 125.6, times cosine of the angle. And VIY is just going to be equal to initial velocity times sine of the angle. So in the x case, this will be 125.6 meters per second times cosine of 30 degrees, which is equal to 108.9 meters per second. And for the VIY, this is going to be equal to the initial velocity of the projectile times sine of 30 degrees, which is equal to 62.8 meters per second. At this point, I then need to answer the questions. First one says, how high does the projectile go? So how high? I want to know my displacement in the y direction. So to see what they're talking about here, I draw a little sketch, and I want to know what's my displacement in the y direction after firing the projectile. Writing down my initial variables now, I know, hey, at the very top of the path of the projectile, the velocity is equal to 0 meters per second, so VFY will be 0. So I get my VY, which is what I'm looking for, VIY, which we know is 62.8 meters per second. Then I have my VFY, which is equal to 0 meters per second. My T is unknown. And I also have my acceleration, which is equal to negative 9.80 meters per second squared. So in this case, my T is missing. Now the formula to use when T is missing is going to be VF y squared equals VI y squared plus 2 times A times dy. Now I solve this for dy. Look, since we're looking at the peak, that VFY is 0. So VIY is going to be equal to the whoa, I'm sorry. I'm actually looking for dy. So I have dy is going to be equal to the negative of VIY squared over 2 times A sub y. And what we get there, putting on the A sub y's, is going to be negative of 62.8 meters per second quantity squared over 2 times negative 9.8 meters per second squared. Plug that into your calculator, and you get that dy is equal to 201.2 meters. Now, part B of this says, how far horizontally did the projectile go? So in part B, we want to find dx. Now we know vx, but we have to find t in this case. But the t is for the whole path. We don't know how long it took to get from when it was launched to when it landed. So we're actually looking out at these points here. T from when it launched to landed. So to find t, we always have to go to the vertical direction. So in the vertical direction, if you notice, dy is equal to 0 meters. It lands at the same height at what it was launched from. We know that VIY is equal to 62.8 meters per second. And we also know that the acceleration in the y direction is going to be g, which is negative 9.8 meters per second squared. I'm looking for t. And with this one, VFY is missing. So the equation I would use for this one is that VFY missing, I use dy equals VI y t plus 1/2 a t squared. And now I have to solve for t. Well, here we know that dy is 0. So I get 0 is equal to 62.8 meters per second times t. 1/2 times negative 9.8 would be negative minus 4.9 t squared. So in order to solve this, I factor out a t, and I get 0 equals t times 62.8 minus 4.9 t. Now, this whole equation is equal to 0. Notice that the left-hand side, right there, is 0. So to get the right-hand side equal to 0, I could either have t equal to 0. There's two roots to this. Or I can get whatever's inside the parentheses and have that be equal to 0. So I'm going to take this back up to the top here and say, well, when I get 62.8 minus 4.9t equals 0, that will also give me 0 for that equation. So working this out, take the t to the other side, I get 62.8 is equal to 4.9t. I'm going to add 4.9t to both sides. Divide by 4.9, divide by 4.9, and I get t is equal to, in this case, 12.8 seconds. Now I can use that to find how far it went, because dx, by the way, that's the t from the time it launched to the time it landed. So dx equals vxt. So dx is going to be equal to, we already figured out vx at the beginning. It's 108.9 meters per second times your time, 12.8 seconds. So this projectile went a total of 1,396 meters, which is the answer to the second one. The real key is being able to find t for the whole path in part B, and that's when your dy is 0, since it landed back horizontally again.